This is 8.3, testing a claim about mean for statistic class when sigma is not known. So this is for the first question. A simple random sample of 40 recorded speeds in miles per hour is obtained from cars traveling on a section of Highway 405 in Los Angeles. The sample has a mean of 68.4 miles per hour with a standard deviation of 5.7 miles per hour. Use a 0.05 significant level to test the claim that the mean speed of all cars is greater than the posted speed limit of 65 miles per hour. So every time when you guys do a hypothesis testing, I always call my students to figure out where is the claims that you need to test, and it's always given the question. For this case, you want to test the claim that the mean speed of all cars is greater than the posted speed limit of 65 miles per hour. So this is your claim. This claim is very important because when you make a conclusion, you have to base on this claim. When you do your hypothesis statements, this is where your claim statements will be. So the first thing you need to go through here is to check your requirement. The requirements that we have here is two requirements when you do the 8.3. The sample has to be simple random sample, the population is normally distributed, or sample size is more than 30, or both. This second one is robust or loose in this case. What's the meaning when I say it's robust or loose? It means that if you have a small sample size that is not greater than 30, then you have to make sure that there is no outliers in the small sample size. Otherwise, if you find it is normally distributed, then it is fine. So in order for us to figure out if a simple random sample, you have to read the question, and if a question stated that this is a simple random sample, then your answer in this case will be yes. If the question did not stated that this is a simple random sample, you cannot assume that it is a simple random sample, so you have to answer no. Next, since our sample size is 40, so which is more than 30 in this case, so that means that the second requirement is also met. So since both of these requirement is met, so in this case we met the requirements, then you will continue to doing a hypothesis statement. In order for us to do the hypothesis statement, which is step number 2, again, your hypothesis statement is based on your claim statement, does not based on your the results that got, which is the mean and standard deviation. So in order for us to write this, because it says that the mean is greater than, so every time when you see the word greater, less than, it's going to be in your null hypothesis. And make sure that you use the symbol mu here, not p, because mu stands for population proportion. P stands for population proportion, which you did in 8.2. So in this case, we want to find that mu in this case is greater than 65 miles per hour. For your null hypothesis 80 is always equal, so your mu in this case is equal to 65 miles per hour. So this is your two hypotheses in this case, and this worth 2 points, and the one above worth also 2 points. Sampling distribution, again the sampling distribution in this case is going to be a t distribution. Later in 8.2 you did z distribution for population proportion, so later on you will do the chi-square and the f distribution in chapter 12 and 11 and 12. Next is the R syntax. Now, since this question provide us the statistic means that they provide us the sample size, the sample mean, and the sample standard deviation, then you have to use the binom. You have to use the t-sum test. That means you have to call the library BSDA and you have to use the t-sum test. So in this case, you have to use type. This is the one that you have to use for your syntax in this case. So so what you need to do for this syntax is some changes here. So when you do the t-sum test that we have here, the mean x is your mean, and it's given us that is 68.4. The standard deviation in this case is given us for the sample is given us by 5.7 miles. The n dot x is your sample size, which is given us by 40. Now this mu is gonna be what is given as what you have in your claim statement, and since this mu is gonna be 65, that is what is given in claim statements, then my mu is 65, and alternative in this case is greater. Why we use greater is because this we are testing for greater. If this is less than, we use the word less. If there is equal, we will use two tilde test in this case. Now before you can do the t-sum test in your R, if you just do the t-sum test here, they will give you an error message. It's because you did not do the library BSDA. So make sure you call your library BSDA first before you do your t-sum test. Something wrong here. Let me see. Oh, double commas here. Sorry. Two commas here. What else? Let me see what's going on. Okay. Sorry about that. My R is up to date, so it's outdated, so I have to reinstall it and get a new up-to-date R. And they also don't like to copy and paste, so actually I have to type it out. So where we start right now is we put in the R syntax, which is the t-sum text, t-sum.test. So in R you put a library BSDA, and then you do the t-sum test, mean x, which is a sample mean 68.4, standard is 5.7, sample size is 40, mu is 65, and alternative in this case is great, or you can use the word greater. So you can tell that when you this is the results you will get. This t equals to 3.7725. That is your test statistic. So your test statistic in this case will be t is equals to 3.7725, and the p-value is given us by over here 0.002685. The df is called the degree of freedom, and you can tell if you're doing this the correct way by looking at the true mean. The true mean in this case is gonna be greater than 65, which is the same as right here, which is your hypothesis testing here is saying that it's greater than 65. So this is how we figure out your results, your test statistics, and the p-value. Now for decision, you're looking for your p-value and your alpha. Since our p-value in this case is 0.002685, and the alpha is given us by the 5%, 0.05, the significant level. So we know that this 0.002685 is less than your alpha 5%. So since your p-value is less than alpha in this case, then we will be rejecting your null hypothesis. So your p-value is less than alpha, we will reject your null hypothesis. So your decision in this case is to reject the null hypothesis. Next, your conclusion. So in order for us to do your conclusion, then you have to look at the table here. So since the original claim, if you read this question, it says that the claim here is greater than 65 miles per hour. So that means that greater means does not include equality. So this is either number 1 or number 2. And then if you look at your decision, you say you're rejecting the null hypothesis. So since we have not included and you reject, so your conclusion will say there is sufficient evidence to support the claim in this case. So this is your conclusion for this question. So the conclusion will be there is sufficient evidence to support the claim. And what is your claim says? The claim says that the mean speed of the all cars is greater than 65 miles per hour. So this is your claim in this case. So usually your claim is always given up by up in the question. And finally the question is asking is that do you agree that the speed of a car is greater than 65 miles per hour? Since you say there is sufficient that to support your claim, so your answer in this case will be yes. If you have it is not sufficient evidence to support the claim, then the answer will be no. So if you look at this table, if you make the conclusion for the first one, then your answer will be yes. If you make the conclusion for the second one, your answer will be no because of the word not. If you make your conclusion on the third one, this is also no. The reason why it's no is because of the word warrant rejection. So rejection means is rejecting, which is negation, no. And the last one, you have the word not and you have the word rejection, so this is like double negation here. So your answer in this case will be yes in this case. Okay, so this is how we figure out how you answer your questions in this case.